Newton's law of cooling. Now, this is a more generalized version of Newton's law of cooling than the one which you studied in precalculus. In precalculus, so let's go over it first and then I'll tell you the differences. So it says that T of t equals e power negative kt times the integral of all this. And now the capital T is the temperature inside the building at time t. So basically this law is used to study the temperature in a building as a function of time. So temperature inside the building at time t. So this is what we used to call as the surrounding temperature when we studied that simpler version of Newton's law of cooling. K is equal to 1 over time constant for the building. M is the outside temperature at time t. Okay. And H is the additional heating rate due to people, lights, machines in the building. And now that's something which we did not consider. We kind of made a simplistic model when we were in pre-calculus. We did not consider the additional heating rate due to people, lights, machines in the building. And then U is equal to rate of change of temperature due to furnace or AC in the building. And that's also something which was missing. We took a very simplistic thing where just you place a hot object in a hot or a cold object in some surroundings. And so you see that now we are considering more factors, and this is therefore more general than the earlier version that you studied. And C is the constant of integration. Okay, so now let's look at this example. On a mild Saturday morning, while people were working inside, the furnace keeps the temperature inside the building at 20 degrees C. Okay. At noon, the furnace is turned off and people go home. The temperature outside is constant, 12 degrees C for the rest of the afternoon. If the time constant for the building is 4 hours, so time constant is K, solution. Time constant is 1 over K. So K will be 1 over time constant. So K will be 1 over 4. When will the temperature inside the building reach 16 degrees C? So, okay. So the temperature inside the building is the T of T. So T of T is equal to 16 degrees C. And the question is, when will this happen? So we have to find the time at which this happens. And now let's figure out the other things. So T is the temperature. Okay. M is the outside temperature at time T. So the temperature outside is constant, which is 12. So M is equal to 12, or let's just write in that line. M is equal to 12. And then, okay, we have taken this into account, Okay. And then the only thing that's left is, so let's go here and see if we know everything. So H is the additional heating rate due to people, lights, and machines in the building. So the additional heating rate is 0 because they simply don't give it to us. So if they don't give that, then we can ignore that. That's 0. Okay. So H is 0 in this case. And then U is the rate of change of temperature due to furnace or air conditioner in the building. So the furnace keeps the temperature inside the building at 20 degrees C. So it means it keeps it as mm, okay. Okay, so here it is. Um, So we are interested in what's happening after noon. So the first sentence is about the morning when the furnace is running, and so the temperature is constant throughout the morning at 20 degrees C. But at noon, the furnace is turned off. So if the furnace is turned off, now the temperature is going to change, and people go home. Oh, okay, okay. So this is not an assumption that there are no people, because at noon they are telling us that people do go home. But we are still assuming that the lighting is gone. They don't specifically mention us. They mention it about the lighting and additional machinery in the building, but that's what we assume, that it's not there because they don't mention it. But people they are telling us are gone. So temperature outside is constant, so that's fine. That's 12. And now the inside temperature, since the furnace is gone at noon, at noon the furnace is off, so there is nothing, no additional heating because of the furnace as well. So the U is also 0 because U is the rate of change of temperature due to furnace. And since the furnace is off, so there is no change of temperature because of the furnace. So U is 0 as well. And at time 0, the temperature will be, remember, the big T is the temperature inside the room. So at time 0, the temperature will be 20. And in this case, the 0 time is the noon time, because the question is about what happens after the furnace turns off at noon. So at noon, basically everything starts, but we take this morning data tells us that when the noon starts, at that time the temperature was 20 in the building, because it was 20 all morning. So it was 20 at noon, but then it would start changing afternoon because the furnace is turned off. Okay, so now we have all the data. And this final thing, the T of 0 equals 20, that will be used to find that C, this C constant of integration. So now let's see. Let's rewrite and substitute all the values. Copy. All right, so T of T we know is 1/4. K is 1/4. So this be negative T over 4 here. This would be 1/4 again. So it'd be T over 4. 1/4. M is 12. H and U are 0. Okay. And so now we need to integrate in the next step. So I'll just copy this much. Okay, so the 12/4 is just a 3. And then the integral of e to the t over 4 would be e to the t over 4 divided by 1/4. So dividing by 1/4 means multiplying by 4 times e to the t over 4. Okay, and then the plus c. So remember, whenever you have e to the ax, the integral is e to the ax divided by a. So in this case, it'd be e to the t over 4 divided by 1 over 4. And dividing by 1 over 4 is like multiplying by 4. But if you don't like that, you can do your u substitution, u equals t over 4. And you'll get that. Okay, and now we use this initial condition, t of 0 equals 20. So in fact, this 1 over 4 right now, just leave it as t of t. Don't substitute this yet. Do it after you found the constant. So t of 0. Now substitute 0 here. This is t of t. And now we substitute t of 0 equals 20. So t is 0. This will be 0. This will be 0. And now t of 0 is 20. Is equal to, okay, let's just do the equation editor. 20 is equal to 3 times 4 is 12, e to the 0 is 1 plus c, so c is equal to 8. So now substitute c is equal to 8 in here. And now you do substitute. We want to find the time when the temperature inside is 16. So now substitute t of t equals 16. And solve for little t. Okay, so let's see. Oh, there's a mistake. There's a mistake because this e to the negative t over 4, that distributes over both of these. It also distributes over the c. So third equation, it will also distribute. So it will distribute over the whole thing. Okay, so here also it distributes over the whole thing. Okay, so 20 is equal to 12 plus c. So it doesn't change the value of c, but it will change this thing. And now it's like that. So it doesn't affect the value of c, but it will affect what happens afterwards. Okay. So now we distribute this e to the negative t over 4 over this one and over the 8. So we get 16 is equal to, so now 3 times 4 is 12. And when you multiply e to the negative t over 4 with e to the t over 4, that just goes away. It's 1. So it's just 12 from the first one. And then from the second one, you get 8 e to the negative t over 4. Okay, so to solve this, you first subtract the 12. All right, so you get 4 equals 8e to the negative t over 4. Then you divide by 4. So when you divide by 4, so 4 divided by 8 is 0.5. So you will get 0.5 is equal to e to the negative t over 4 divided by 8. And now take ln. ln 0.5 equals negative t over 4. And now multiply by negative 4, so you will get t equals 2.7726. T is equal to 2.7726, and the units will be hours. So everything is in hours. So 2.7726 hours. Okay. 2.77 would be 2.8 to the nearest 10th. Okay, so now the second part is you just repeat the same. Now the time constant is 2 hours instead of 4 hours. So just change the value of k accordingly. Remember, k is 1 over time constant. So basically you will just repeat the problem. You will repeat the problem from the beginning. Instead of k being 1 over 4, it was 1 over 4 when the time constant was 4 hours. And now when the time constant is 2 hours, the k will be 1 over 2. And that will change this one to 1 negative t by 2, this one to t by 2, and here it will be 1 by 2. And then you see what happens. Just repeat everything. Okay.